All right. For Algebra 2, we are doing compound inequalities, lesson 1.7 here. We're combining two inequalities into one statement. Um, Sorry, these maybe look a little um, rewritten over there because they are actually. Um, but so there's two different ways that we can do inequalities and make it a compound inequality. The first one is a conjunction. Okay, so we have a conjunction, uses the word and. Okay, so knowing that it has the word and, if we look over, it says it's a solution that must satisfy both inequalities. Okay, so it's an and statement. It must satisfy both. We also consider this an intersection, okay, like we've been doing um, with, or that you did in geometry. More, you had intersections and unions. So a conjunction is an intersection of the inequalities. And the symbol there is an upside down V. All right, then the disjunction. Next up is our disjunction. Okay, so it's an or statement. So again, if we look at the definition, the solution can satisfy either inequality. It doesn't have to be both, just one or the other. So that's called the union, okay, because it can be in any of those areas. It doesn't have to be in all of them. And it is a V when we denote it. All right, so let's look and get started on trying to solve some of these. So in example 1, it says solve 5x plus 9 is less than 24 and negative 3x minus 7 is less than 14. Or sorry, is greater than 14. All right, so we need to solve them separately. We're going to solve it just like any equation. So we need to get x by itself. And we see that we have an addition, right? We have adding 9 here. So we need to do the opposite and get rid of that. So we're going to subtract 9 from both sides. So then we have 5x equals 24 minus 9 is 15. All right, so now we have some multiplication happening between the 5 and the x. So we're going to divide by 5 on both sides and get x equals 15 divided by 5 is 3. Actually, it's not equals though. Maybe you caught that. It should be less than or equal to. All of these should be less than or equal to. We need to keep that sign. Next up, if we look at the next one, we have negative 3x minus 7 is greater than 14. Okay, so here we have a minus 7. So we need to undo that with addition. So we're going to add 7 to both sides. Once we add 7, we should have negative 3x is greater than 14 plus 7 is 21. All right, then negative 3 is being multiplied by x, so we're going to divide by negative 3 on both sides. So then that will leave us negative 3x divided by negative 3 is x. We divided by a negative number. Does anybody know what happens? There, we flip the sign. So we flip the sign when, sign, pardon me, not sign. Okay, we flip the sign when you multiply or divide by negative number. Okay, so we did have a greater than sign, and then we still had the greater than sign. We changed it when we divided by the negative 3. So now it's less than suddenly. And 21 divided by negative 3 is negative 7. So x is less than negative 7. Okay, the other thing we should do is graph this. So if I had a graph there so we could see it, we can find, because this is an and, which is an intersection. All right, so let me graph this. We should have I think that would take care of it. Let's see, if I put 0 here, because we're going to 3. So 1, 2, 3, and then negative 7. Oh, I need more. 1, 2, 3, 4, 5, 6, 7. I always go a little bit longer. So there's negative 7. All right, so to graph these, the first one, x is less than or equal to 3. All right, so I'm going to have, since it's less than or equal to, I'm going to have a circle that's filled in at 3, and it's going to come all the way back. All right, then for my next one, x is less than negative 7. It's a less than, so negative 7, I'm going to have an open circle, and I would bring that on back, or you could graph that above. But then we need to look at it's an and statement. It's an intersection. It must satisfy both equations. So in this case, in order to satisfy both equations, it's going to have to be, the solution is x is less than negative 7. That's the only one that would satisfy both, because all the numbers down here also satisfy the numbers that were going to be here. Okay, so the solution is x is less than negative 7 is our real solution because it's an intersection. All right, if we wanted to graph the answer, the solution as a whole, we could do that separately. But the problem didn't actually tell us to, so we don't have to do that. But let me show you what that would look like. So if I was going to graph the solution, I would probably just have negative 7, negative 6, negative 8 here, and I would graph with an open circle at negative 7 and my arrow to show that. All right, so let's look at example 2. Let's clear this off and look at example 2. We're solving 8 is less than 5x minus 7 is less than 18. All right, so the first thing you need to do is to rewrite it as two equations. All right, so I'm going to have 8 is less than 5x minus 7 as 1. And then the other one is going to be 5x minus 7 is less than 18. All right, hopefully you can see where I did that, where I got those numbers from. Like the first set came from here. I took the number in front of my inequality and the expression after. And the second set came with the expression over to the other inequality. Okay, so then we solve them separately. So for the first one, I'm going to add 7 to both sides. Okay, and then I'm going to have 8 plus 7 is 15 is less than 5x. I'll divide by 5. And 15 divided by 5 is 3. So 3 is less than x. I'm not flipping my inequality because I didn't multiply or divide by a negative number. All right, let's try the next one. Same thing, I'm going to add 7 to both sides. All right, this time I'm going to have 5x is less than 18 plus 7, which is 25. All right, so then next I divide by 5 again, same reasons, and I'm left with x is less than 5. 25 divided by 5 is 5. Remember this is a disjunction, it's a union, so it can fulfill either of these. So again, let's look at a number line here to help us think through our answer. So let's see, we have positives. Let's do 0 here. 1, 2, 3, 4, 5, 6. All right, our first one says 3 is less than x. 3 is less than x. So I'm actually going to do this a little bit different. So 3 is less than x, but it might help if I read this as x is greater than 3, right? Because that's what I want to know. So I'm going to draw an open circle, and x's are greater than 3. So I just reversed that first one, so my x came first. It helps my brain work. It might help your brain work too. The next one says x is less than 5. So at 5, we have x is less than 5. Okay. All right. All right, so this is still an intersection, just like the one we did before. So we want to find where these intersect. Where do the answers intersect? Where do they overlap? Well, it's pretty easy to see once we graph it that they overlap in between here. So my graph is going to be an open circle on the 3, an open circle on the 5, and that's my connection. So this is my solution, which is 3 is less than x, but less than 5. Okay, so that's my solution to this compound inequality. It has to be in between these two. All right, very nice. Give you a minute on that one. Now let's look at the next one. Okay, so we're solving 9x plus 6 is greater than 60, or, notice the or, so now we're switching over to the disjunction. Okay, so or negative 2 times the quantity x plus 7 minus 3x is greater than or equal to 11. So some of these equations are getting a little more complicated, as well as working on the inequality. Okay, so let's start with that first one. The same steps. We have to solve the inequalities. So in the first one, I'm going to subtract 6 and be left with 9x is greater than 54. I would divide by 9, and that would leave me with x is greater than 54 divided by 9 is 6. Okay, so x is greater than 6. On the second one, we need to do some distributive property. Negative 2x, okay, negative 2 plus 7 is going to be plus negative 14, minus 3x is greater than or equal to 11. All right, so you don't have to have the plus and negative 14. If you want to write minus 14, that's okay. But next step would be that I'm going to add 14 to both sides. And I'm going to go ahead in this, that's a 14. I'm going to combine my like terms here because those both have an x. So I'm going to do those in the same step. They don't affect each other. So negative 2x minus 3x is going to be negative 5x is greater than or equal to 11 plus 14 is 25. Okay. Then I'm going to divide by negative 5 on both sides. Remember, that's going to make my sign flip. I'm going to go ahead and flip my sign to be a less than or equal to, because it's a negative number. So that's going to give me x is less than or equal to 25 divided by negative 5 is negative 5, because I flipped my sign. All right, very nice. And then let's go ahead and look at the graph of that. So let's see, here's 0. I need 1, 2, 3, 4, 5, 6, 7. I always go one more. 1, 2, 3, 4, 5, 6. And there's negative 5. All right, so there's my number line to start with. And so let's look at x is greater than 6. So I'm going to have an open circle and my line going to the right. And if I look at x is less than or equal to negative 5, I'm going to have a closed circle at negative 5 because it's less than or equal. The equal sign means it's closed. And it's less than, so it's going to go to the left. So my answer, like I have to, is x is less than or equal to negative 5 or x is greater than 6. Okay, that's my final answer. It just can't be anywhere in between those. All right. Hopefully you guys are catching on. Graphing is super helpful in solving these problems. Okay, let's flip over to the back. Okay, there it goes. My board didn't want to clear for a minute. All right, let's flip over to the back and solve. This time we have just the symbols here. So in A, Okay, we have 2x plus 3 is less than negative 7. And that symbol there, which symbol is that? Good. It's an intersection. It's an and. It's a conjunction. So we're looking at a conjunction, an and statement here. So 9x minus 4 is greater than 5. So let's start there. We solve them one at a time. So 2x plus 3, we're going to subtract 3, gives me 2x is less than negative 10. Divide by 2, and that's going to give me x is less than negative 5. On the other one, we will add 4 first, which is going to result in the inequality 9x is greater than 9. And then we'll divide by 9. And the result there is going to be x is greater than 1. Because we didn't divide by any negative numbers, so our numbers didn't flip. All right, so let's look at the graph here. So we need a negative 5 and a 1. So let's see, we'll do 0, 1, 2, negative 1, 2, 3, 4, 5, 6. So there's my negative 5. All right, so let's graph these. The first one, x is less than negative 5. So an open circle to the left. The other one, x is greater than 1. Open circle to the right. Here's the kicker for this. It's an and statement. Remember, it must satisfy both inequalities. There is nothing that will satisfy both of these. There's no number that they have in common. So this one is no solution. Okay, because the graphs have nothing in common. No solution because graphs have nothing in common. Oh, there we go. Nothing in common. All right, so we would put this O with a slash through it for no solution. All right, so that's our answer there. Okay, let's look at B then. B is 2x plus 3 is greater than or equal to negative 7. And our symbol there is what? Good, it's a disjunction. Okay, so it's an or statement or a union instead of an intersection this time. Maybe I should have wrote that over here when I wrote the and, that we were looking for the intersection. All right, so now we're looking for the union. All right, same process. We're going to solve and then see what we can have in common or what we can get from our graph. So first up, let's subtract 3, and that will give us 2x is greater than or equal to negative 10. Let's divide by 2 on both sides, and that will result in x is greater than or equal to negative 5. Good. The other equation, let's do plus 4 because it's being subtracted. So we'll do the inverse of that. Results in 9x is less than or equal to 9. Okay, so these are these are the exact same problems. So I guess I didn't have to show you this, but I want to see you go through and practice. Next up is we're going to divide by 9, and that results in x is less than or equal to 1. 1. Okay, so they're the exact same problem. One is an intersection, one is a union. You probably already noticed this. But the graph is what's important here. That's what I want you to see, is the graph is what's important. So let's do the same thing. I don't know why we did that with my number line. 0, 1, 2. So there's my 1. And let's see, 0, 1, 2, 3, 4, 5, 6. So there's my negative 5. Let me extend my line out there. Okay, so now I've got my line. And let's graph these. So this time, I guess it's a little bit different because I've changed my I've changed the symbols a little bit, but x is greater than or equal to 5. So we're going to have a filled in circle, and we could graph it above until we get our solution, possibly. So it's going to be filled in circle, and it's greater than, so it's going to the right. All right, the next one, x is less than or equal to 1. So it's going to be a filled in circle, and it's going to be headed to the left. All right, so those are our two graphs. Now, this is a union, right? It's a disjunction, a union. It's an or statement. So the solution can satisfy either inequality, which means in this case, any number on the number line is the answer. Absolutely any number. So the solution here is all real numbers. So we would put the real number sign. Okay, because the solution to the union, that's to the union, and can satisfy either equation. And I guess, so it's all real numbers because the solution to the union can satisfy either equation. Pretty awesome stuff there. Okay, then let's try example 5. We're going to get into this word problem. Check that out. And we'll go from there. All right, so Carrie has received scores of 79, 87, and 95 on her first 3 tests. What scores could she receive on her next test and maintain a B test average? So we're talking from 80 inclusive to 90 exclusive. Okay, so the first thing is we need to get her test average. Okay, we want their test average. All right, so to find an average, we add up all the scores and divide by how many tests she took. So she has a 79 plus an 87 plus a 95 plus, I'm going to label this next one as T, right? Because we want to know what score she would receive on her next test to maintain a B. All right, so all 4 of those are going to be divided by 4. Okay, and the reason we do this is because we have to know what we're looking at here to get her there. So 79 plus 87 plus 95 is 261 plus T divided by 4. So there our average, the test average. All right, but now we need to take this a step further because we can't really solve for her average yet because we want to know you could solve what she has to get. Like you could solve this and you know what T would be. But it says what scores, so we want to write it as a range of scores. What scores could she receive on her next test to maintain a B average? Now, this 80 inclusive and 90 inclusive are important because 80 is the lowest grade, so that's less than or equal to, that she could get. So her score has to be higher than this, right? Her score has to be up here. So her score has to be greater. If we read this backwards, okay, if you read it this way, her score has to be greater than or equal to get an 80. Or 90. Okay, if we read it this way, her score has to be less than this amount to be less than 90. Okay, to stay in that B range. If she got higher than a score, she would get in the A range, but we want to keep her in that B range. So, but her score is this number. We need to insert that right there. So our inequality would be 80 is less than or equal to 261 plus T divided by 4 less than 90. All right, and then you can solve this. All right, so the first thing to do to solve this, we actually solve them at the same time. I might blow your mind a little bit, but just copy it down, follow along and copy down today, and we can talk about it tomorrow some. So I'm going to multiply this whole thing by 4. Okay, so 4 times 80 is 320. So that's going to be less than or equal to. When I multiply this section, 261 plus t divided by 4, the 4 in the denominator just cancels out. So it leaves me with 261 plus t is less than. And then 90 times 4 is 360. So I am distributing this 4 to every single part inside. Okay. Now I can subtract 261 from all 3 parts of this inequality, which is going to result in 320 minus 261 is 59. So I'm going to keep less than or equals to my variable t, my less than, and 360 minus 261 is 99. So here is my final inequality, which tells me that her score must be greater than or equal to 59, but less than 99. All right, that is it for today. Your homework is on the front. We will do a review day tomorrow, so be ready for that. I'll see you then.